Okay, AP Computer Science A. This is a sort of note sheet that I will let you guys use on your test. And it just might be a good reference for the future also. I'm going to kind of try and summarize all the different things from this unit on this single sheet of paper. So I would print one out for yourself and fill it out for your own self. I will let you use your own version filled out on tests, not someone else's, not mine. So print a blank one out. It's in the shared folder, and then follow along. Okay. So there's these are just this unit's all about the fundamentals, just a lot of the basic syntax things, just little ideas that you need to understand and that we just use a lot in Java. And so there's different data types. There's primitive, which we've been using a lot. And primitive would include like int, double, boolean. Now, there are other primitive types, but these are the ones that we're going to make use of that you'll be expected to know for your AP test. Now, int is integer, but you have to type int. Double is an integer is just, it's a nice whole number, positive, negative, 0. Double is like a decimal, floating point decimal. Okay. Boolean is true or false. That's all it can be, true or false. Now, just to add some little notes about these things, just to kind of show how we create, how we declare a variable of this type, how we initialize it. So, we could call it int x equals 5. That's like the line of code that you would have. Now, what does it actually look like? Well, x is more of like a reference to the spot in the memory where this value is going to be stored. So it's not literally x equals 5, but x is tied to a place in the memory. So it's kind of like a location, and we can replace what is in that location. We can put other values in, but it's kind of like it's a container, and we're putting a 5 in it for right now. But we could change what's in it later. Okay. Same idea for a double. You kind of think of it as like a container. It's a spot in the memory. And so, for instance, just an example, double cost. So that's called declaring the variable. We're declaring variable cost of type double. And then when you say equals and you put a value to it, the very first time it's called initializing or assigning a value to it. And so it's kind of like cost is the name location, and 199 is what is at that location. Good names for true, false, Boolean. Not that you have to do this, but this often makes sense, and we want to come up with good descriptive variable names in general. So a general rule for naming a Boolean variable would be is something. Okay, like is on, is off, is imaginary. Okay, so the variable name itself is sort of conveying the sense of it is or it isn't something. It's true or it's false. So, Boolean is on, and then you can decide what to initially set it to, true, false. Now, if you don't initialize your variables, Java will by default give certain values. Like for numbers, like ints and doubles, it'll give it a 0. Boolean, I believe it'll set it to false. if you don't give it a value at first. But I want you guys to not rely on that right now. I want you to go ahead and initialize the variables. Okay, so let's see. There are some different types of, I'm going to move down here to the bottom half of the page. We're going to talk about operators. Now, operators, you kind of think of in math, you have operations. So operators are things that, do something else. So like in math, we have arithmetic operators. And so you can add things, you can subtract, you can multiply. It's kind of more of like a asterisk star symbol on your keyboard. It's right above the 8. You can divide with the slash like a fraction. The percent symbol does not find the percent. It's called the modulus operator. And what it does is it gives you the remainder of a division, which we've found can be helpful for certain things. So for instance, just a little example, 5 modulus 2 would say, well, what's 5 divided by 2? Well, technically it's 2.5, 2.5. But it's going to say, well, how many it just wants the leftover. So 2 goes into 5 2 whole times, but there's a leftover of 1, right? That's the remainder, like if you do long division. Now, there's some other shortcuts to arithmetic that we'll probably take advantage of. You don't have to, but, for multiple choice questions on the AP test, you'll have to understand how these work. And then you might also like to use them as you become comfortable with them. Probably forcing yourself to use them will make you become more comfortable with them. But these are little shortcuts that can help you write less code. So like plus equals, for instance, would be like if x equals 20, all right, and then we say x plus equals 22. What it does is it takes the previous value of x and adds 22 to it. Okay, so x is now 42. Now you probably need to write small on this sheet, by the way, too. There's a lot of stuff going to fit on here. Okay, so that means that this right here is the same as the statement x equals x plus 22. So it's a little shorter way of writing. And we often do this kind of stuff in Java, so otherwise they wouldn't have made it a convenient shortcut. Now there's the same shortcut for all the other operators. So you can do minus equals, which will take the previous value and subtract another value from it. I mean, it saves a little bit of work. I mean, I guess it really just saves you writing that x. You got to put the operator first, though. You can do multiply equals. You can do division equals. You can do modulus equals. So let's see what would that mean if you did modulus equals. Let's say you had x modulus equals 60. Like, what does that mean? That's the same thing as x equals x modulus 60. Okay. There's some other shortcuts that I think we use a ton. Plus. Okay. That they refer to that as an increment, to add something, add 1. Okay. So what it does is it adds 1 to the current value. and we do that a lot. It's very helpful. There's also a decrement, subtract 1. So we often are adding 1 over and over again. So this is a nice shortcut. So just as, let's see an example, I could write a little example up here for the increment thing. Let's say x equals 3. If you do x plus plus, now x is 4. Okay. It's the same as x equals x plus 1. Okay. That would also give you 4, right? It's also the same as x plus equals 1. So you could use that other shortcut right there. But if you're just adding 1, plus plus is the way to go. So that's a bunch of arithmetic operators. We also have what are called relational operators. And so relational means it's comparing how two things are related to each other. Okay. Now, if you want to see if two things are the same, equal, with primitives, use equal equals, okay, or use exclamation equals, which means not equal. So this is for equals, and this is for not equals. In general, in Java, if you put exclamation in front of something, relational or Boolean or whatever, it means the opposite. So we use these with primitives, ints, doubles. It doesn't work with objects like strings. And so we'll put that on here too, but we've talked about that. You can do less than, you can do greater than, you can do less than or equal to. You actually just put the equal sign after it, which kind of makes sense. You can't put a bar underneath. You do greater than or equal to. Okay. Now, for objects, just as a comment right here, objects, for instance, like strings, which we've been working with a lot. We're going to deal with a lot of objects. This is object-oriented programming, by the way. You would take a variable and you'd say dot equals. You don't underline it. I'm just emphasizing that, to some other variable or some other string. So you need to have two strings compared to each other. They got to be the same object type. And you use dot equals, and you put parentheses. That's instead of equal equals. So in this case right here, equal equals, you do not do it that way. You use dot equals to compare objects. Now, sometimes you can get away with that on strings. I would recommend you don't, because I don't know if you'll truly understand when you can or why you can get away with it. So let's try and be just strict and use dot equals with all objects, including strings. There are other operators called conditional operators. And so conditional means with logic. If there's multiple things that, it's like multiple conditions. So if you want to do and, so like in math, there's and or. And that has meaning. If you have two conditions in the word and, that means both conditions have to be true for the whole thing to be true. If you have or, then only one has to be true, but both could be true. So for and, we use this and symbol. I have a hard time writing it. It's kind of like that. But it's got to be double. You got to put two of them. Okay? Or is two vertical lines, which are right above the backslash key, above the enter button on the right side of your keyboard. The other one that I already mentioned is the exclamation symbol, which just means not. So not true, not. Yeah. So those are conditional operators. Now let's go ahead and jump back to the top here. And here I want to talk about control structures. So, control structures. So we're going to break this down in two categories. There's decision making, and we've been using these a lot. So that could be like an if or an if else, right? And this goes back to just kind of logic. You have if then statements in math, or and that's what this is like. And so, just as a little example, we could say if x is greater than 5, you'd put it in parentheses. That's the thing you're testing for. And when this is true, then you do this, whatever it is, right? If it's false, then you do nothing in this situation. Okay. Now, if you do want to do something in the false situation, that's when you use an if else. So you could say if x is greater than 5, do this. And we could do multiple else ifs. We could put a bunch of them. So we could say just if else, but we could also put some other ifs in between. If that's not true, well, is this true? If that's not true, is this true? So we could keep going, and put other tests for other situations. Do something different. And then for the last one, I would never do an else if for the last one. Okay. For the very last one, I would just say else. Okay. So last possible don't need to test. Usually you don't need to test, and Java might not compile if you do this because it'll be scared that there won't be, something that'll happen for sure. So, of course, I want you to comment these and else, right? And if I want you to close your comment, you're closing curly braces, even on this one, and if, right? And else if. So you guys can use this, as a reference when you're taking your test, all the things I actually also want you to show style-wise and stuff. So that's decision making. Another control structure is iteration. And iteration means that we do something, we do multiple steps of something, and we do something over and over again. And so we use for loops. We use something else called a for each loop, which I have not talked about yet. So I don't think I'm going to put anything on here for that. And we use while loops. So we're going to do this later, some later unit. But for loops, the way we write them is we write for. You got to create some kind of counter or something, int. You got to say what it is. Usually we're probably using ints for our counter, and then you got to initialize it. You got to give it a name. This is like you're declaring and initializing a variable here. If it makes sense to use something different in counter, like if you're doing an array, you probably use index. Then you have a control statement that's going to stop it. And then you have something that increments your counter, which is often plus plus, but it could be minus minus, it could be something else. So this starts this, and then it checks against that, right? And then this increments it, and that's the same as like counter equals counter plus 1, which you could write, but counter plus plus is a lot easier. So what happens is you go through this and you do something and you do it over and over again. But the first time you do something and it checks, okay, is this less than 10? Okay, let's do this. And then after it's finished this, it then goes up here, it increments your counter, and then it checks it again. And then if counter's not less than 10, then it stops. So that's your for loop. Little example. Now a while loop would be something like this. And you could always do what you do with a for loop with a while loop. But for loop is kind of a nice way of doing it. While loops we can use for some other situations that for loops can't work with. So you might create some variable and say, well, while x is less than 5, do something like x equals x plus 2. So it says, well, x is 1, so less than 5, good. Then do this, and now it's 3, and you check back up here, still less than 5. Then we do this, it's 5 now. 5 is not less than 5, so it's done. Of course, comment your ending curly braces. So that's a while. So for loop's more when you know how many times you want to do something. While loop is more that you're doing something and you kind of want to just test to see if something's true or false to decide whether to keep going or not. Okay. We go down here to the bottom and talk about objects, the object class. Now in Java, the all classes belong to the object class. So we're going to talk about this later this year, that objects can have other objects in them or belong to other objects. Now, there's a lot of object classes that we're not necessarily using yet, but we've seen some of these and used some things from them. So there's the integer object class. It's a capital I, and it's spelled all the way out. This is not the same as int. Now, what it does is it holds an int and allows you to do things to ints. So we used it. There's this method. It's kind of like program in the integer class called parseInt that we used. And what it does is it takes a string and it changes it into a number. So like if the string is quotations 2, it's just more the symbol 2, like that's what we print out. If you want it to actually be like the value of 2, then use this. There's also a class for doubles that probably has a similar method to this, but we haven't seen it. There's this string class. Now, classes always start with capital letters, so that's how you know it's an object. We've been using strings a lot. So, quick example of the string is a string name. Now, in general, when you create an object, which we weren't creating integer or double objects, we were using some of their methods, but if you create an object, you always say new, and you say the object name, and then you have to give it some kind of argument. Some of them you don't have to give anything, but here this would create a new string with the string Sam. Now, by the way, string classes, we create strings so much that Java has created a shortcut just for strings to where you don't have to write the new thing. Now you have to put the quotations around it, otherwise it'll think it's a variable. If you put quotations, Java will be like, oh, these are just symbols. So we can get away with this. And I think at this point, I'm okay with that. But the new string Sam is the more proper way of doing it, the way that you have to do it to other new objects. Now, these variables are a little different than sort of the ones that we use for primitives. The primitives actually are the location in the memory, whereas this, we're going to do things to strings. We're going to, there's methods we can use and stuff like that. So this is kind of like more, try and illustrate it. There's a spot in the memory for name, and it's kind of like it's more of, we call it a reference. Okay, reference, and it's kind of more of like a remote control that allows you to change values to another spot in the memory that holds the string. Okay, this will make more sense in future units. We've used the math class quite a bit. So there's a bunch of methods in the math class that we use. We're not really creating math objects, but we might use math dot square root, and put a 9 in there, and then that would give you 3. Or another big one, math.random. There are different random number generators, but math.random is the one you will be expected to understand the AP test. It takes no arguments, but you have to put the empty parentheses. Now, math.random, just some extra notes on math.random. It gives you a value from 0 to 1, a decimal, a double, okay? But, it might actually give you, it might actually give you a 0, but it will never give you 1. So it's kind of like it's giving you 0 to 0.99999, like that, right? So with that in mind, we can do things to it to manipulate it to give us other values. Like we can scale it, which means we could multiply it by a value to make the values bigger. So if we did 10 times math.random, it would give you values 0 to 9.999, right? It will give you those values, but 10 times bigger. So it could go all the way down 0 up to 9.999. We can shift it. And so that means kind of like add something to it to give bigger numbers. So you could do something like 10 times math.random, and then add a value to it afterwards. Okay, so that would give you 10 to 19.999. All right. We could cast it, which we often like to do, make it into an integer. Okay. And so it changes, what casting does is it changes a double to an integer, casting to an int. You got to put it in these parentheses in front of it. And the way it does that is just by truncating. It doesn't round, it just cuts off the decimals. Okay. So, for instance, like if you do it to here, if you were to do it to this one, you would get 0 to 9. This one you get 10 to 19. Right? If you were to truncate, if you were to cast it. What if you want 10 to 20 inclusive? So this is 10 to 20 inclusive, 10 excluding 20. But let's say you actually want to go all the way up to 20, then you would want to do math.random times 10 plus 1. And then you'd add 10, and then you could cast it. So you'd want to multiply by one more, because then that would give you 10 to 21, 10 to 20.9999. And when you cast it, it would chop it off and you'd get 10 to 20. Okay. Here, some other objects that we've been using are arrays. Okay. Now, specifically one-dimensional arrays. Later, we will talk about two-dimensional arrays, which will be fun, but let's get the hang of one-dimensional arrays first. Also later, we'll talk about another similar structure called an array list. Okay. And we'll use it for similar things, but it works a little differently, which is good for certain things and bad for others. Now, just some quick notes: how you initialize an array, or how you declare a variable of array type. You say the type of thing that's going to be in it, and you put empty brackets, and then you could put the name of your array. So that's called declaring the array. And then initializing it. Well, yeah, they call it instantiating. So with an object, when you actually, right now that the object doesn't exist, there's just a spot in the memory with a reference waiting for it. So to actually create it, we have to say equals new, like other objects. And then you also put the type of thing in there. And then you also put the size. Okay. So this is called declaring, whereas this is called instantiating, which is sort of like creating it for the first time. And then to initialize it, that's when you put a value in. So this doesn't hold values yet. So there's different ways to do that, but you can access each location by putting in 0 to the end of the size. So this is going to be 0 to 19 spots. There's 20 spots, but we always start at 0. So you could just one by one place values in, but we've talked about some other ways of doing it. A lot of times you use for loops. And the last one is at spot 19. And you put whatever you want in it. Okay? So now the idea here, kind of visually, is that this is kind of like a bunch of boxes all lined up. So let me draw a little picture right here. This is kind of what I imagine. This isn't really how it's stored in the memory, but this would have a 3 there, a 2 there. There would be a bunch of other spots, and then the last spot has a -5. Now, the locations, which we call a lot of times we call the index. First one's 0, 1, 2, 3, all the way up to spot 19. Okay? Because there's only 20 spots. If you end up trying to do something in spot 20, like index 20, you'll get an error. A lot of times we use for loops to traverse an array, to go through it, do something, look for something. And so for loops are really handy with arrays. So just as a quick example, let's say, now usually I use the variable name index for the counter because that makes a lot of sense for an array. I wouldn't say counter in this case, I'd say index because keeping track of the spots. And then your condition, usually in this spot, we want to, instead of putting hard coding 20, we want to make Java tell us the length of the array, numbers dot length. Now the length will come back 20, and we always want to be less than 20, because if we're equal to 20, we're getting an error, out of bounds error. And then you would have an incrementer. So then you would, do something to each spot. You might say numbers index equals something, or you can print them all out, something like that. So, okay. Now, just as another little maybe tip for your test, just to kind of get you thinking. Let's talk about like in math, we have things called series or sequences. A sequence is like a list of numbers that usually has a pattern. So we're not doing anything here right now. We're going to do these later. Okay, but just as a little side note right here, let's say an arithmetic sequence, something you learn about in Algebra 1. Okay. Now, arithmetic sequence is where something, the same number is added to the next number. So let's say an example of arithmetic sequence might be 1, 5, 9, 13, 17. Okay. So we're adding 4 each time, and this list of numbers is called the sequence. And arithmetic means that you're adding. There's things called geometric sequences where you're multiplying. So how you would do this is you could say, well, numbers, you got to have a value to start with, because everything's based off the previous value, right? So the idea of a sequence is the next spot is based off the previous spot. So you got to have a previous spot. So the first spot, we're going to have to actually put the value in, okay? But then we would probably use a for loop for int index. And we're going to start at spot 1 as 0, because we already have spot 0. And then we're going to say index less than numbers dot length. And then we're going to do index plus plus. So I'm kind of squeezing all this in. So that's the first line of the for loop. And then inside, we could say, okay, numbers index equals, and the idea is that you want to take the previous value and add 4 to it. Take the previous value and add 4 to it. Take the previous value and add 4 to it. And we can start at whatever. So I don't want you to hard code, whatever that previous value is, I want to add 4 to it. So how do we access the previous value? Well, we do numbers index minus 1. That will give you access to the previous spot, and then we will add 4 to it. And then that would fill the array. The for loop would just fill the array for you automatically, starting at 1 and add 4 each time. Or whatever you want to do to it. You could actually use the previous 2 spots. Say, well, let's add the previous 2 spots. Well, then you would say numbers index equals numbers index minus 1 plus numbers index minus 2. Now you got to be careful, because at that point you need 2 previous spots filled already before you start the for loop. And you also got to make sure you don't get indexed out of bounds. The fact that we do index minus 1 in here, if we had a 0 here, we get an error saying we went out of bounds, because we're trying to access numbers spot -1, but they start at 0. You never have an index at -1. So let's see. There's a couple other things I think we should add to our note page. Just that might be helpful. Like, just how do we start a program? I'll just kind of squeeze it in up here at the top. I'm going to write small. So we do public. I'm going to leave some room here. Public class. And then you use whatever name it has, starting with a capital letter. And then you have your curly braces. And then you tab in and you say public static void main, parentheses, string with a capital S, empty brackets, args, right? Okay, let's see. You know, and then you put some stuff in here, and then you say end method main common unit curly brace, and then here you say end class, whatever name it has. Okay, this is always main though. It's always the main method on the outside. But also possibly, and I'm gonna put it over here because I'm kind of running out of room. But at the top here, if you want to do J option pane, which I might ask you to do, before the top you have to say import Java X dot swing dot J option pane, and write this clearly. It's capital J, capital O, capital P. Okay, everything else in here is lowercase. And then just some other notes about using JOption pane. Inside, you might create like a variable input to get the value from the user. And the way you get the value from the user is you say J option pane dot show input dialog, and then you put some kind of message in there that you want them to see that tells them what to give you. So that gets the value as a string, and then you want to change it to a number. So then you could say int number or whatever you want to do, whatever variable makes sense. I don't want to use these variable names all the time. I'm just this example. So then we use that method from the integer object class, capital I integer dot parse int. And then we put the input value in there, which is a string, and it changes it to a number for us, into a primitive int. Okay, well, I think that is kind of everything I think would, be helpful here. So now you have a nice note sheet. And you can always go back through the video and kind of rewind and pause the places that maybe you feel like you don't have, but you want to have this really, this is gonna be really nice. This is the only notes I'm gonna let you use on your test. Just on your unit test. Each unit will have a new sheet, and then you can always use the old sheets on your future units too. So this has a lot of good information on it, a lot of, everything kind of on one sheet. I mean, this just might be good to have around when you're just, trying to type up your programs in the future anyways. So that's it. Make sure you're ready for your test.